Our hypothesis is that the batteries in colder temperatures will discharge quicker than those that are in room temperature conditions. Batteries store and release energy by moving electrons from one end of the battery to the other. These ends are known as the anode and the cathode. When recharging, electrons move from the cathode to the anode rather than the other way around. Batteries work because of the movement of electrons. Knowing this, because lower temperatures cause chemical reactions to happen slower, the battery will create less current, but will still need to produce the same amount of power as before in order to keep all those motors running. Therefore, devices with batteries in colder temperatures will run out quicker.
First, we needed to build a device that would drain the battery. We settled on building a device in the shops that used 9 4-volt batteries that would effectively drain the battery. Once the device was done, we tested the battery at room temperature 3 times. After we got that result, we tested it in a fridge at 34 degrees Fahrenheit, and we ran that test 3 times.
In this portion of the video, I'll be going to the results and then later on the conclusion section of our experiment. So looking at our lithium-ion battery performing in room temperature, which was at 73 degrees Fahrenheit, test 1 lasted at 1 hour, 56 minutes and 13 seconds. Test 2 lasted at 1 hour, 55 minutes and 45 seconds. And test 3 lasted at 1 hour, 53 minutes and 29 seconds. And one trend that we saw here right off the bat is that after each test, the battery life lasts less. And this is also the same case for the battery that performs in the cold temperature, which is at 34 degrees Fahrenheit. So for test 1 for the one in cold temperature lasts 1 hour, 54 minutes and 58 seconds. Test 2 lasts 1 hour, 53 minutes and 49 seconds. Test 3 lasts 1 hour, 50 minutes and 16 seconds. And the big takeaway from our results is that the battery in cold temperature and the cold temperature lasts less in almost every test.
We'll move on to the conclusion section of our experiment. For the small scale, one thing that we can speculate from this experiment is that devices utilizing lithium-ion batteries will perform worse in colder temperatures. And the same could probably be said about other types of batteries. Other types of batteries perform similarly to lithium-ion batteries. But in order for us to have a more concrete answer, we would need to perform hundreds and hundreds of more drainage tests. Now, on the other hand, from our research, our results made sense. From our research, we saw that the chemical reaction occurring in the battery, which produces current, will be slowed down and create less current. And from this, it all made sense. Now we move on to next steps if we were to have more time on this experiment in order to progress it. And I've already mentioned this before, and one thing we would want to do is have more drainage tests. And the reason why we were only able to have 3 is because these drainage tests take long amounts of time. And it takes quite a while for the battery to charge, and it's just a whole amount of time being used up. But also one other thing is that we had originally planned to have a warm environment drainage test, but since we were not able to find reliable heat sources, we did not really want to risk the possibility of causing the explosion, having the fire department come in and all that. But for things we wanted to change to see some other stuff, what if we use different types of motors, or what if we drain different amounts of power? What if we drain less power? What if we drain more power at a time, seeing if results would differ? Or using different types of batteries, seeing if they would react the same way as a lithium-ion battery would.